Lesson 13.3 is about mean absolute deviation. So how do you calculate the mean absolute deviation of a data set? One way to describe a set of data is with the mean. However, the mean, remember, is the average. However, two data sets may have the same mean but look very different when they're graphed. When interpreting data sets, it's important to consider how far away the data values are from the mean or the average. Okay, so I'm not actually going to use counters. I'm just going to use red dots for our when we make our dot plots. The number of magazine subscriptions sold by two teams of students for a drama club fundraiser is shown below. The mean number of subscription for each team is 4. Okay, so the way they got that 4 was they took 3 plus 3 plus 4 plus 5 plus 5, added it all up. That's 6, 10, 20. Divide 20 by 4, or I mean 5, because there's 5. 1, 2, 3, 4, 5 data sets. So the mean is 4. Here we have 1 plus 4 is 5, plus 7 is 12, plus 8 is 20. So once again, 20 divided by 5 is 4. So that's why the mean is 4. Okay, they added up all the values divided by the number of pieces of data and got the mean of 4 for both of them. All right, now make a dot plot for each data set using the counters for dots. Draw a vertical line through the mean. Okay, and so they did one number line for us, so I drew a second one, and here's our mean for the second set of data. Okay. Count to find the distance between each counter and the mean. Write the distance underneath each counter. So they put a 3. So 3, they put a red dot there, and that is 1 space away from the mean. There's a second dot here, again 1 space away from the mean. 3, 3. 4 is 0 spaces from the mean because it's on the mean. 5 and 5, and these are also 1 and 1 space away, and this one's a 0. All right, so that was team A. All right, team B. So I made one for team B here. Team B. All right, we have 0. We have 1. We have 4. We have 7 and 8. All right, and the space from the 0 to the 4, this distance is 4. 1, 2, 3, 4 spaces away. This one is 3 spaces away. Pardon me. This one is 0 spaces away. This one is 3 spaces away. This one is 4 spaces away. All right. So obviously these are all much closer to the mean. These are much more spread out. Okay, so we're going to figure out what that means now that we've gathered up our data. So they put the first 1 down for us, another 1, a 0, a 1, and a 1. So we're going to take the average of all of the distances now. We're finding the mean of the distances for each data set. So 1, 1, 0, 1, 1. We add that up. We have 1, 2, 3, 4. 4 divided by 5 is 0.8. In other words, it's real close to the mean. That's what that means. This number is very small. So it's very, very close to the mean. Here we have 4, 3, 0, 3 and 4. all divided by 5, because there's 1, 2, 3, 4, 5 pieces of data. That's 7, 14. 14 divided by 5, which is 2.8. Okay, so there's a much bigger distance from the mean than there is with Team B than there is with Team A. All right, which data set, Team A or B, looks more spread out on your dot plot? Well, definitely Team B, right? Looks more spread out on the dot plot. Which data set had a greater average distance from the mean? Again, Team B. They had a greater average distance. They had 2.8 instead of 0.8. All right, and final question. Explain how these two facts are connected. Well, the more spread out the data set is, the greater the mean of the distances. Meaning, let's see if I can explain that better. The more spread out, the greater the mean of the distances is going to be. This number gets bigger the more spread out the data sets are. If they're all clustered really close together, then the mean of the distances is going to be very, very small. The more spread out this gets, the bigger this number is going to get. All right, so let's see how we can write that. Let's say the more spread out the data set is. That's a comma, the greater the mean or the average of the distances of data values from the mean. Mean, not meme. Mean of the data set will be. Set will be. All right. The table shows the average distance from the mean for the heights of players on two basketball teams. All right. So the Chargers have an average distance from the mean of 2.8 and the Wolverines 1.5. Tell which set of heights are more spread out, and how do you know? Well, this one's more spread out because it's a bigger number. So this is the average distance from the mean. In other words, how far away the points are from the mean, the average number. So the bigger the number is, the further spread out those little red dots are. Okay, so the Chargers are more spread out. Chargers should be capitalized because it's a proper name. Because the distance from the mean is greater than the Wolverines. All right, the mean of the distances of data values from the mean of the data set is called the mean absolute derivation. In other words, these numbers that we just were working with, that's what they're talking about. As you learned in the investigation, mean absolute deviation is a way of describing how spread out a data set is. The dot plot shows the ages of gymnasts registered for the school team. The mean of the ages is 10. Find the mean absolute deviation of the data. Label each dot with its distance from the mean. So what is our mean? The mean is 10, so this is our mean. Okay, so this one would be what? 2, 2, 2, 2, right? Because they're 2 apart. This one's only 1 from 10. These are all 0 because they're right on 10. 10 to 12 is 2, 2, 2, and 13 would be 3. Okay, let's take a look at this. Is it possible for the mean absolute deviation of a data set to be 0? Well, yeah, it's possible if all the data, yes. Okay, so if every value in the data set, so if, for example, in this case, the age of every single gymnast on the team was 10, well then, yeah, the mean absolute deviation would just be 0, right? Because they're all, there's no distance from the mean to the data. It is all right here. It's not spread out. It's all on this line. So that's what that would mean. So it is possible for it to be 0. So the answer is yes. If all the data set is the same number. If the entire data set, it's a D, is just one number. All right, so let's get back to what we were doing before here. So we need to take all these 2's and put them on there. A 1, a whole bunch of 0's, some more 2's. Whoops, I did something wrong. 1, 2, 3, 4. 1, 2, 3, 4. 1. Oh, I did too many 0's. Okay, that should be a 2. And that should be a 3. Sorry about that. Okay. 2, 4, 6, 8, 9, 11, 13, 15, 18. And how many? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we're dividing by 12. 18 divided by 12 is 1 point. Let's move this over. 5. So 1.5. So let's see, the mean absolute deviation is 1.5. Okay, so let's see. So the mean absolute deviation of the data is 1.5 years. All right. Here we go. One more time. Okay, let's do 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 0, 1, 2, 4, 5, 6, 7, 8, 9, 10. Okay, so find the mean absolute deviation for both data sets. Oh, this one over here too? Okay, so on this day, we had, let's see, 5, 6, 6. What is our mean? Oh, our mean is 7. They did give us that. Okay. 6, 6, 8, and 10. So this is 2 away, then 1 away for both of those, 1 away for that one, and 3. And we have 1, 2, 3, 4, 5 pieces of data. So 2 plus 1, 3, 4, 5, 8 divided by 5. Is that right? Yes. Okay. And so 8 divided by 5 is 1.6. Okay, here we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 3, 5, 7, 9. What did I do wrong? Oh, I should have had a 0. Sorry. Okay, so we, 11, let's see. So we've got 10, 11, 12, and 13 out here. All right, and my mean, the number, is still 7. And we have 1, 3, 7, 11, and 13. And that puts us at 6, 4, 0, 1, 2, 3, 4, 6. All divided by 5. Let's see. Oh, so this one, sorry, this one was 1.6 laps. Okay, here we have 10 and 10, 24. Okay, so the absolute mean deviation was 4 for this one, 1.6 for this one. The data set of Laura instead of Shauna, so the Laura's data set is more spread out because the absolute, the mean absolute deviation of her data is 4 laps, which is greater. Okay. Okay, here we go. Our mean is 7 books. Books read each semester. The mean absolute deviation. So we have 3 plus 2, 4, 6, 8. I guess I should do it this way. Plus 1 plus 2 plus 3 plus 3. Getting way over here. Plus 4. All divided by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that would be 3 plus 8 is 11, 12, 14, 15, 16, 17, 20, 24. 24 divided by 10 equals 2.4. So the absolute, so the mean absolute deviation is 2.4. Here we have, our mean is 29 pounds. So we have 3 plus 3 plus 3 plus 2 plus 2 plus 3 plus 4 plus 6, all divided by 1, 2, 3, 4, 5, 6, 7, 8. This is 3 plus 3 plus 3 is 9, 11, 13, 16, 20, 26. 26 divided by 8 equals 3.25. So the mean absolute deviation is 3.25 pounds. This was books. Okay, so hopefully you can do the PMT at this point in time. This video was a little long, but this is kind of a complicated concept. Good luck.